Hey guys, it's Sam. Today we're going to talk about different types of rigid gas permeable lenses, and more importantly, how to know when to select which type. So we're going to talk about spherical lenses, we're going to talk about front toric, back toric, and bi-toric lenses. So I had this question posed to me on this channel. It said, I'm having a hard time figuring out what type of lens to select, because you'll encounter questions on your Ncle which will give you K readings, a refraction, and it'll say, what type of lens should we select for this patient? And you'll have to determine, the pros, the cons, and which lens they're expecting you to choose. So it's really important. Learning some of these foundational principles will definitely help you guide you through the exam. So let's jump right in. First, we want to talk about spherical gas permeable lenses. So what's neat with gas permeable lenses is that a spherical lens can correct for astigmatism if it's corneal astigmatism. I'm going to write an example on the board here. Okay, so we have 42/44 at 90. I'm going to put a prescription down here. -1, -2 at 180. So if we're posed with these K readings and this refraction, the question might say, what type of lens should we fit? So there's a number of things we want to identify with this. So let's just work through this, and just some teachable moments will come out of this. So 42/44. So first we see that our flatter K is this 42. Right? Because when you're talking about a corneal dioptric strength, a K reading, the lower the number, the flatter. Conversely, oppositely, with a radius of curvature like 8.3 versus 8.7, the lower the number, the steeper. So remember that. 44 is our steeper K, and it's showing it at 44 at 90. So that means on our cornea, right, that's our cornea, the 90 degree or vertical meridian. That's our 44 base curve on that meridian, where it has a 42 K reading along the 180. So this is a regular astigmatism, a regular, not irregular. So we're going to assume that the other meridian, the strongest and the weakest meridians are represented, is 90 degrees apart. So 42 will be at 180. So we have at 90, we've got a 44K. At 180, we have a 42K. But here's our prescription. So from our prescription, we see that there are 2 diopters of astigmatism present, or cylinder power. So what we need to look for is, does the refraction, the cylinder power of the refraction, does that match the cylinder present in the K readings? And the cylinder is the difference between the K readings, from the steepest meridian to the flattest meridian, right? This is our steepest power, this is our flattest. So is that 2 diopters of difference? And it is. So our corneal astigmatism, from our K readings we can see, matches our refractive prescription, our 2 diopters. So what we can deduce from this is that this patient, all of their astigmatism is corneal astigmatism. So we have 2 diopters. Let's see, our 2 major meridians. We have a -1 on the 180, so that's showing our strength. Then we transpose to get the power 90 degrees away, so you have -3 along the 90. Right, so that is our, our flattest and our strongest power. And another learning point here is, the cornea is a plus powered lens, right? So think of it, it's convex. It's not concave like a minus power lens. So because the cornea is steeper in the 90 degree meridian, because it's steeper in the 90 degree meridian, it's with the rule of astigmatism, you need more minus power in that meridian, right, to neutralize that astigmatism. So I digress. It's 2 diopters of corneal astigmatism, 2 diopters of refractive astigmatism. So we know that a spherical gas permeable lens can correct up to 3 diopters of with the rule astigmatism up to 2 diopters of against the rule astigmatism. And you may see that it says that a spherical gas permeable lens can correct up to 2.5 diopters of astigmatism. So that's kind of a rough estimate, but in general it's going to be anywhere up to 3 diopters of with the rule, 2 diopters of against the rule. And we can correct for a toric prescription with a spherical gas permeable. That's a lot to say, because when you have the cornea, that lens, when we apply that lens to the cornea, it's going to fill in with the tear film, and it's going to provide a new smooth refractive surface, right? That lens is actually going to overtake the cornea, and it's going to create, a spherical surface throughout. So it can correct for that. So actually with this example, we could use a spherical gas permeable lens. There's nothing abnormal about it. Our Ks match our refractive cylinder. I'm going to go ahead and erase this example. Obviously, you can review that as much as you need. But there's a lot in there, and you can see how there's a lot of teachable moments and things that you could use on different examples from that one example. And this is probably a good point to do a plug, but if these videos are helpful, I'd love for you to share them on social media or to just subscribe to the channel, please send me comments if you have questions. I do appreciate that. It's very helpful. So next I want to talk about front toric lenses. So, I mentioned we're going to talk about spherical, front toric, back toric, BiTorque. Front toric lenses, just like the name sounds, we have the cylindrical component on the front of the lens, not on the ocular surface, which is your base curve of a contact lens, the central posterior curve. So it has a spherical base curve, right? The ocular, what's touching the cornea. The front surface is where you have your various meridians, right? Your various base curves. So with a front toric, what you need to know is that you're going to use them with, that's funny, minimal corneal astigmatism, right? So, and the way you could think about this is the front of the contact lens, right, isn't touching the cornea. So a mnemonic device for this is just thinking front surface toric. Okay, I'm going to use those for patients who don't have a lot of corneal astigmatism because the toric component on them is on the front of the lens. It's not the side of the lens that's touching the eye. It's not the base curve of the lens. So front surface toric, minimal corneal astigmatism, right? So we're going to do, it'll be like less than 1 diopter. You also want to have greater than a diopter of residual astigmatism or lenticular astigmatism to warrant using the lens, right? So we want over 1 diopter of, let's just say, lenticular. So I'm saying lenticular because we know that astigmatism primarily will come from the cornea, which is, the primary lens of the eye. It's 43 diopters of strength. And then you have the crystalline lens, which is inside the eye, and that's about 17 diopters of strength. But either one of those lenses can possess astigmatism, cannot be completely spherical, and you can have subluxation of the lens, different things inside the eye that can create astigmatism that wouldn't show in a keratometer reading, right? Because a keratometer is just measuring the corneal steepness. It's just actually, and here's another, just remember this, the keratometer measures just a 3 millimeter zone on the cornea of the corneal cap. So it's not measuring the full cornea, but just that small area, which is enough for contact lens fitting in general. But your cornea is going to flatten towards the periphery. But there's all sorts of astigmatism. There's even scleral astigmatism that could be present. But so just remember that front surface toric, you're dealing more so with the residual astigmatism. It could be after you fit a lens and there's an over refraction and it's not coming from the cornea. It's that residual astigmatism. So one thing you need to know about front surface toric is it needs prism ballast or some sort of stabilization method, because with the back surface toric or BiTorque lenses, having that various radius of curvatures on the back surface, the ocular surface of the contact lens, helps stabilize it. But when with the front surface toric, since we put it on the front, it doesn't stabilize as well. So you really need that weight of the prism on the lens. It's usually base down prism. It'll cause the lens to ride low, right? Because normally we want gas permeable lenses to ride a little high with a lid attachment. Again, I digress. Front surface torque. Let's do an example. So I have, let's see, 42/4250 at 180. A prescription, I have -1, -2 at, let's say, 90. All right, so, and actually, yeah, that'll work. So what we have here, we see, first off, kind of like what we were doing, identify how much corneal astigmatism is present. 42 to 4250, those are our two major meridians. There's just a half a diopter of difference, so not much corneal astigmatism. So what we want to look at here, our key point to this example is manifest in the refraction. It's showing 2 diopters of astigmatism. Well, that 2 diopters isn't coming from the cornea, right? So we would say that this, patient is a candidate for a front toric rigid gas permeable contact lens. That's your clue that you're going to see on the test to make you think front toric. Oh, it's not corneal astigmatism. So not too bad. I think a lot of times we overcomplicate these things. And even, in the real world, when you're not just trying to pass a test for the NCLE, most doctors and optometrists and physicians, they're relying very heavily on the lens manufacturer for the fitting principles, but you do need to know the foundations and the basics, and you need to know, be able to understand the lenses, and especially if you're evaluating the fit, and to be able to make tweaks to the lens after the diagnostic lens. But there are certain cues like this that we just went over that you'll kind of know which lens to lean on. So next I want to talk about Bi-Toric rigid gas permeable. Bi-Toric lenses, they're also, you might see them referred to as base curve toric. Again, let's just think through it, kind of slow down. The base curve of a contact lens is on the back surface. It's on the ocular surface. It's also referred to as a central posterior curve. So these are just Bi-Toric lenses. So where do we think the astigmatism component is going to be? On the back surface. So they have a spherical front surface, and then they have various meridians on the back surface of the lens, right? You have your different radiuses of curvature on the back. I'm going to put up an example. So I have 42/46 at 90. This is going to be a little more involved example. I'm really looking forward to this as far as something we can work through together and get a kind of learning point out of. So the key, before we go any further, is with Bi-Toric lenses, you're going to look for one thing. You're going to look for the corneal astigmatism to be about 2/3 the strength of the total overall refractive astigmatism. So remember that fraction, 2/3. So that's, like 4 out of 6. So you're going to want it to be that proper proportion. Doesn't have to be exact, but I know on the test, that's what you're going to have to kind of look out for, the 2/3 ratio. Bi-Toric lenses, again, you've got the astigmatism component on the back of the lens. You have a spherical front surface. The front surface being spherical and the back surface is toric, so it's going to help stabilize the lens a little bit. So let's look at this example. Again, let's just pull some things out of it. So this is our flattest K, 42. Our steepest K is 46. So our steepest K is on the 90. So again, with the rule of astigmatism, steepest K is at 90. If our steepest K was at 180, it'd be against the rule, or 30 degrees within that. And then you could have oblique astigmatism. So just something to be looking out for with the rule of astigmatism. So we have a -2 strength at 180. I'm going to write that down. So a 180 axis, -2. We have to find our strength at 90. So we would have what? -9 at 90. If we transpose that. So, but what's interesting about this prescription is over 4 diopters, right? So we have the -9, -2. So what we're going to want to do, we're actually going to want to compensate for vertex distance. We can't forget to do that, right? Put your prescription in minus cylinder form, compensate for vertex distance. So it's on our optical cross already. Well, all lenses that are refracted, again, let's pretend they're out here. They're acting more plus the further away they are from the eye. Kind of like, people put their glasses down on their nose to increase magnification. It's a good way to remember it. But so contact lenses, we're always making the contact lens prescription more plus or less minus. So a -9, if we compensate for vertex distance, for the sake of this video, we're not going to work it out. It's -8.12. And again, there's multiple videos I have up on vertex distance. So I definitely implore you to go check those out if you need to refresh on that. But you could always, once you get used to it, you can kind of guesstimate about what it should be anyway to help you on the exam. Then we're going to take it off the optical cross. So we're going to start with our most plus number to take it off, which is a -2. It's less minus. -2, record the axis, 180. We're going to say, how far do we get from a -2 to a -8.12? That distance is -6.12. Okay, so our new refraction, -2, -6.12, axis 180. So I'm going to just kind of get rid of this for clarity's sake. Not that this is clear at all. -2, -6.12, axis 180. Now we can compare what is our corneal astigmatism. 42 to 46, that's 4 diopters of corneal astigmatism. And then we have 6 diopters, 6.12 diopters of refractive astigmatism, right? So our manifest refraction. So that is the 2/3 ratio. That's your magic ratio you're looking for. So corneal astigmatism is 2/3 of the refractive astigmatism. You're going to think Bi-Toric, also known as like the base curve toric rigid gas permeable lens. That's your clue on those. So again, watch that, review it. There's a couple different steps in there. And now we are going to get to our last type of contact lens we're going to talk about today, which is a Bi-Toric contact lens. And shockingly, just like the name suggests, you have a toric front surface, you have a toric back surface of the lens, right? You have multiple radius of curvature on the front as well as on the back. These lenses, pretty much you're going to use them if the front surface toric or the back toric or the spherical gas permeable, if they're not working well, you could always lean on a Bi-Toric lens. These are so customizable, especially nowadays. So it's a great lens to go to. Your clue on these lenses, though, kind of like we've had the other clues for like back toric, is 2/3 corneal to total astigmatism. Front toric, we're going to do minimal corneal astigmatism, a lot more residual astigmatism. So your clue with the Bi-Toric, just think high corneal astigmatism. High corneal astigmatism, check it against the 2/3 rule. If it doesn't quite fit in that range, and it doesn't have to be exact, but if it's not super close, then you're probably going to be using a Bi-Toric lens if the corneal astigmatism looks really high on it. So let me put up a quick example here. 42/47 at 90. We'll do -1, -6, axis 180. Okay, just again, we're going to just really hammer in some points here. Steeper at 90. So if it's steeper at 90, again, that's that with the rule astigmatism. So then one thing we have to notice, we have a 6 diopter cylinder. We're not going to get by without compensating for vertex distance. So let's go ahead and put it on our optical cross. So let's get our 180. So our power at 180 is -1. Our power at 90 is going to be -7. Well, again, we know that a -7 is going to come more plus power or less minus in contact lens form. So we're going to turn that into a -650. Negative 1 at 180, we're going to take it off the cross here, as they say. So negative 1, axis 180. From a negative 1 to a minus 650, we're going to go minus 550 is our distance traveled. Right? Because when we take it off of the optical cross after you compensate for vertex distance in each meridian, what you need to do then is kind of, I think of it like a lensometer power drum. If I'm going from a negative 1 to a negative 650, I'm asking myself, how far am I traveling? And that's your new cylinder power. So our new refraction, that's our K readings there. So again, we have, what, 5 diopters of a corneal cylinder, 5.5 diopters of refractive cylinder. That's not that 2/3 ratio. So we're not going to just automatically go to like BiTorque on that. So I'm gonna go ahead and we're gonna select BiTorque for our answer, right? And also we know that's way too much astigmatism for a spherical gas permeable lens to take care of. So I hope this video has been helpful. Keep sending me your suggestions. I'm really hoping to build up a library of content so that, you know, anyone who wants to take their NCLE has some visual representation where it's kind of accessible to all to be able to get the information they need to pass the test. I know when I was studying or in my studies still, sometimes I'm like laboring over different articles or trying to find an answer to something that I may not understand. So I kind of condense it myself into what I know that I would be looking for, just like the short version to make it click. And that's what I'm really trying to present here. So I hope it's helpful. Please, I love your comments and your feedback and your thumbs up and all that good stuff. So I'll see you soon. Thank you so much.